we're doing chapter 2 now. And in this chapter, we're going to be talking about functions, which is a relation in which each element of the domain is paired with exactly one element of the range. We'll also be talking about relations, which is a set of ordered pairs. Let me give you some examples of that. This is a function, because each of these numbers in the domain has one number in the range. Each has their own, no big deal. This is not a function, because as you can see, this number here goes with two numbers on the other side. 17 goes with 8, but so does 46, and it also goes with 92, so that's not a function. Here, as you can see, are some relations. They are the domain part of this whole thing here, so they're all these numbers over here. Alright, next, we'll be doing chapter 4. As you can see, I'm doing all the even numbers right now. In this chapter, we'll be talking about adding and subtracting matrices. A matrices can be added and subtracted if and only if it has the same dimensions. The dimensions are if it has like 2 rows and 3 columns, or 4 rows and 10 columns, that kind of thing. Like how many is in each thing. I'll also be talking about multiplying matrices. You can multiply matrices if the numbers of columns in the first matrix is equal to the number of rows in the second matrix. So it basically means they have to be able to line up so they can, multiply. Here's an example of the multiplying. As you can see, we got these numbers in here. We're going to multiply them by 3. So we move down here. So 2 times 3, 8 times 3, negative 3 times 3, 5 times 3, negative 9 times 3, and 2 times 3. Well, 2 times 3 is going to equal 6. 8 times 3 is going to equal 24. Negative 3 times 3 is going to equal 9. 5 times 3 is going to equal 15. Negative 9 times 3 is going to equal negative 27. And 2 times 3 is going to equal 6. And that is going to be what it is. See? As you can see in multiplying matrices, you have to multiply each of the numbers on the inside of the matrix to the number that you want to multiply. Okay. Next, we're going to be talking about adding matrices. So here we got matrix A, matrix B. And we're going to be adding them together. And in order to do this, as you can see, I underlined the matrix numbers with yellow. You're going to add each of them to their corresponding one in this one. So 4 from the first one plus negative 3, and then negative 6 plus 7, 2 plus 5, and 3 plus negative 9. And of course, all those numbers are going to equal 1, 1, 7, and negative 6. Awesome. Alright, next we're going to talk about subtracting. It's going to be great. Okay, so first, you're obviously going to have your 2 matrices here. And again, I bracketed the second one. And again, we're going to do the corresponding ones. So 9 and 3, 2 and 6, negative 4 and 8, and 7 and negative 2. And when you get all that together, it's going to be 6, negative 4, negative 12, and 9. Alright. Next, we're doing chapter 5. As you can see, it's beautiful. Okay, for this one, we're going to be solving quadratic equations with quadratic formula. The equation for that is ax squared plus bx plus c. We'll also be talking about solving quadratic inequalities, which you replace the inequality symbol with an equal symbol, then solve that equation. An inequality symbol is like that little v that looks like this to make it seem if it's greater or lesser, but we're going to turn those into equal signs instead. First is solving with a quadratic equation. What you have here is a negative 5x plus 3. And then you see you do all this math down here. And eventually you're going to get all the way down to 0.625. And then you do some more math, and your x is going to be 0.625, and your y is going to be 5. And then you put those in your little parentheses, and you'll have your x and y. So that's really good. And then the last is solving a quadratic inequality. As you can see here, we're going to take that, and it's going to be turned into an equal sign. Equals. Then you're going to put some parentheses in there, and eventually your answer is going to be negative 2 and 3. Alright, I think that's it.